Excellent. So, welcome everyone to this month's AI in construction. Actually, at this point, we're doing more than one a month, but there's been a lot of, excuse me, a lot of talk and a lot of products that are coming out into market. Some of which I think are making claims that are maybe a little extravagant, but also I find the way people talk about some of what you can do in AI is maybe skipping over some of the hard part. But the other thing that made me want to do this particular topic is for me, like the next level of using AI is to recognize that with a little extra work, you can make it more reliable. Whether you're using just ChatGPT on your own and you've created better prompts or even done the system prompt, or if you're building, an agent or some kind of an automation. So I thought it would be worth spending a little time talking about the reality of making reliable products or reliable prompts or reliable functions. Those of you that have some software experience will recognize a lot of this, and you'll see some of what I'm saying. But I also want to talk not just about that, but about the kind of the pace of AI progress in general, because that's another one that kind of relates to this. So I'll start real quick by letting you all know. I know you guys, a lot of you know, I've been doing this at least monthly for the last bit more than a year. Kind of organized it. It's been here in a playlist, but we've organized it a little bit better. So a lot of the old stuff, things that are a month old, 2, 3 months old, are all here for you guys to check out. I have a link at the very end that'll help you find that. So just kind of letting you know that today is a deep dive in a I think really important topic. But along the way, we've got a lot of things that we're talking about. A lot of focus lately on agents, actually. Right. So with that, let's dive into it. So what we've all seen, and this is kind of the reason for even talking about AI as much as we have been lately, is it can be pretty dazzling. It can be cool that you give it a prompt and it comes back with a reasonable answer. We've never had anything like that before. So it's relatively easy, as I say, to make it do cool looking things. These cool looking things then make us assume it can do these cool things all the time because we're so used to software that's already been through the ringer behind the scenes that we weren't part of it, but we assume that that's going to be true, and of course it's not. So what winds up happening is people get a little disappointed because it wasn't reliable, or it did some things but then it didn't do some things, or it hallucinated. Although again, you see that less now, especially if you're pointing it at documents. But the broader point is it's a very powerful tool, but or a set of tools, but as a result, you need to respect the fact that it may go in directions you didn't want it to until you put it through a little bit of that debugging ringer. And that's what we're going to spend some time on today. So the way I'd like folks to think about demos and these cool things that they see is that if you imagine a list of all the things that a product or a feature could ever do or could ever encounter, can you group them by how often they happen, how probable they are to happen? Look, you're maybe not going to get a normal distribution. I did that because everybody understands the bell curve and it's easy to kind of understand. But the reality is that, it could be anywhere. And again, that's not so important. What is important is to think that at one end of this distribution, of this kind of list of how often things happen, you've got a few things that happen all the time, an increasing number of things that happen lots or most of the time. And then you get into the thing that we often call edge cases, things that don't happen that often, right? And there's still a lot of them that don't happen that often. But anyway, so it's a good way of thinking about what's going to happen when your prompt or your product hits reality. It's going to do well on things that happen often, and it's going to do pretty well on things that happen most of the time, and it's going to start running out of gas and breaking when things that happen rarely happen. The problem is an individual thing that happens rarely might not, by definition, happen very often. But in aggregate, things that happen rarely are likely to happen a lot. I know that's a really weird sentence, but if you think of all the unlikely things, if that's an awful lot of things that might happen, one of them is going to show up pretty frequently, but it's really hard to know which one is going to show up. That's the problem here. That's why we call them edge cases. So again, those of you who've dealt with software will recognize this. The problem is now we've got pretty sophisticated functions in the hands of people that have never been exposed to this reality of software, that under the hood, companies like mine, like the Link and you name it, Procore, everybody, they've got just teams of people that are running around testing and testing and testing and constantly debugging and adding a little bit of a patch here or a thing here. It's one of the reasons why even products like, I'm not going to mention them, but some really big name products have gone down in the last year. And you're like, wait a minute, you guys have been here a decade. How did that happen? It's because as you start to build things that you run into in a combination of factors you've never seen before, and suddenly things break. So welcome to the wonderful world of software development. Now, nobody's suggesting that users of generative AI need to become software developers or anywhere near that rigorous. However, as is often the case, there's good lessons to be learned from people that do it professionally while you're doing it not so professionally, but still want to get some good results. And this is what I like to say: the right half sucks. This is where debugging happens. And if you talk to any professional developer or product manager, you'll get the look on their face is unmistakable when you talk about debugging and edge cases. It's everyone has the same experience. Um, and like the joke that you hear people say that the first 90% of a code project will take 90% of the development time. The last 10% of the project will take the other 90% of the development time. And what this comes, it's obviously it's a joke, but it's why it's so hard to predict very often when your product is going to be ready for production. Often the debugging is just brutal. And this is one of the reasons why developers often have really long nights, because they're chasing down that last little bit. So as you think about AI, recognize that something somebody strung together pretty quickly to prove a point hasn't gone through this. So they're at the first 50%, not even the first 90%. But also when you see people doing products that are really early and promising how good it's going to get later, you run into a situation that we've seen with AI. We've seen with a lot of things, to be honest, but AI for sure. Um, I kind of had to stop here, and I think a lot of people kind of know that, but again, we seem to forget when we're buying something or listening to something, or people are telling us how wonderful the world is going to be in a year or 2 years. And the practical reality is getting something to go from proving it's possible to proving it's reliable is a really big leap, and often a lot more painful than people know or recognize. And again, part of today's discussion is, okay, but how can I do some of that so that my own prompts can be more reliable, more useful, better for me? The example I like to talk about, those of you who were paying attention to the AI space in the kind of in the late noughts will remember that around 2016, 2017, actually even as early as 2015, Elon Musk was giving speeches about how self-driving cars were right around the corner. Not that he's ever done that kind of thing before. The man absolutely is phenomenal, but he's famous for these unrealistic timelines. Well, it wasn't just him. I remember getting in arguments with people in 2018 about whether 2019 their level 5 self-driving Mercedes was going to be working. Well, clearly that didn't work out. And the problem here is that people looked at that early progress that led us to believe it would just keep going, and that's not how it goes. At the very end, I'm going to talk to you a little bit about progress, but I want to focus on the demos for the moment. But anyway, it gives you an idea of how a cool demo can really throw people off. And usually we're not dealing with something as big as self-driving cars, but we are seeing things a lot where people are thinking, okay, it was able to extract some useful information from the data, from the documents that I threw in there. And people sort of take that and walk away, as opposed to saying, well, hang on a minute, I'm going to try that a few different times, and then I'm going to check and make sure it got everything that I'm looking for, or it worked the way I needed to, or so on and so forth. We're at risk right now because of how buttoned up the outputs of AI often are, that we think it's doing more than it's doing, and we think it's more rigorous than it is. So why does this matter? There's a bunch of reasons, and I've talked about some of them, but the one that really gets me interested and excited is AI is quickly giving tools to people that don't know how to make software to really make some trouble for themselves. But at the bottom, there are three companies. There's more than this. These are just the three that I know of or that I've worked with that allow a non-developer to write a prompt and create code and create a deployable product. I've done that specifically with Replit, excuse me. How's that for a slip of the tongue? I think that the issue is we're assuming because it did deployed software that looks cool, that we've done 90% of the job. And the reality is we have not. We've done maybe 10%. Because now you have to go in and tweak it so that it's creating the buttons that you want and it looks like you want and all that. And even then, there's a limit to what prompt-based creation for the moment is going to be able to do. But all that is a little downstream. That's kind of a UI, and they're going to continue to develop, smarter and smarter and figure it out. A lot of these companies have been doing this for less than a year or maybe a year. There's still a long way to go in terms of learning how to make products that a non-developer can use to make software. But the point is, if we're not approaching this with the humility to say, great, it stood something up, now the hard work starts, how am I going to approach that rather than just putting it off and which is what most people will do and say, I'll get to it later. The best way to get started on something is to just create a plan because then it seems achievable, especially for something truly new. And we'll talk a little bit about that because the cool thing is right as people are doing this, the other bunch, well, another bunch of funded startups, but also people that are just out there doing this, have really been spending time on evaluations, on debugging tools, all these other things that will make it so that you don't need the technical rigor and the technical capability of a developer to do some of what they do. Again, this is not saying that developers are going away. I think that's a bit of a red herring, but it does mean that as tools come about where you can create a little automation or you can, bolt something onto your Excel, your Google Sheets, and that's really where I think you're going to see some really impressive things where you can take a Lovable or a Replit and say, I want something where I can drop a Google document into it and it's going to do these things, useful things, excuse me. I think that's where you're going to find things like Replit really makes sense because it'll allow individuals to do things that are software-like. But again, to get that to work, you're going to have to be humble and say, great, I got it to work a little. Now let's make sure it works every time so I don't have to think about it again. This really is that to me, the next level of usefulness of generative AI is respecting the fact that it can do amazing things, but I'm probably going to have a little homework to do to get us there. So I've kind of hinted at this before, but even prompting needs debugging. I don't know if anyone here has seen really long, sophisticated prompts, but when you get into real production, these can be 2 or 3 pages long, which is pretty wild. Nobody writes that at a go. You get there because you've tried it and you've realized, oh, I got to make sure this is in there. As I say, too often people try a prompt, it doesn't work, or it kind of works, and then we just stop thinking that the AI was the problem when actually we probably could have gotten it to do what we want. We just had to spend some time playing around. So to get really good results, you got to try different prompts, tweaking, adding new phrasing, often new blank. I obviously didn't debug this slide, but new clauses or new items, and especially examples. So one of the things you don't hear, I think, enough in prompting is if you can give it examples, it really narrows down the possibilities that the AI will be dealing with. So as you think about that, I'd like to say that debugging isn't just a set of things you do, it's an attitude. And that's kind of what I was getting at before is that, good developers, they're determined problem solvers. This is actually when you're hiring people, one of the things to look out for is, are these the people that loved problems when they were young, that loved puzzles? Because they stick with it until they figure it out. This is also, I think, why math and software development often go together because good people that are good at math are often good at it because they stick with the problem until they figure it out. So, it doesn't mean you need to become a developer, but recognizing that attitude is something you can talk yourself into, that you can say, today, I'm going to settle into this one and I'm going to stick with it until I figure it out or at least make real progress. That's what a developer does. That's what a problem solver does. That's what you probably do in some other part of your life as well. But the point is, we don't always assume that that's what we need to do with AI. Typically, you're hearing the opposite, that it'll just do things, that it'll work for us. It does things you could never see software do before. All of that is true. But to make it work, you don't get it for free. You got to get in there and have the attitude of a developer. So you've heard me say in other venues that AI is not magic. Unfortunately, we have a bad tendency of seeing it do really cool things and thinking it's magic, and it's not. You got to work to get it right. the work is not always as painful as I'm implying. If you're asking it to do something really rigorous, really difficult, yes, it can be hard. But a lot of what you really want isn't that hard, and it might only take five, six, seven steps. But recognize that you're going to need to do that sometimes. But the point I'm making here is once you do, you have a tool. You've got a cognitive helper anytime you need it. And that's pretty cool. So saying, look, I've spent the time to have five prompts. And anytime I drop my let's say my receipts, it's going to automatically do what I need, put them in the right format and send it off, or give me something I can export into, whatever I needed, wherever I needed to go, the email to my company or into my own accounting system, whatever it might be. Or, I get these documents from from some colleague or some, company that I'm working with, and they're a pain and they're badly formatted. I've trained it so that I can scan them or they're PDFs and I can pop them in. The prompt always works and always spits out what I need. As we start thinking about how AI can help us, the barrier, in my view, to everyday use of AI to just make little parts of your life better is saying, I'm going to put in the work. I'm going to say, I'm going to give this thing 4 hours to debug it, make it work reliably, but now I have it. For the rest of the year until AI changes, or for the next 2 years, I have this tool and I now don't have to spend the time on whatever it was I just automated. That's what kind of brings us to the next thing is it's not just an attitude, it's a skill. So there's things you can do that are learnable. So for non-devs, it doesn't mean, like a joke, it's not advanced placement math. You don't have to get as deep as they do writing tests and all that other stuff. Just make a table. Just put structure around it. Put your goal at the top. Another thing that we often skip is articulating what I actually want this thing to do. We're going to see in a moment that's really critical. Put your goal at the top of that table, put your prompts on the left-hand side and your results on the right. And then a third column about why your result wasn't good enough. I'll show you an example in just a sec. The biggest thing that I find people don't know how to do that aren't developers or product managers is figure out what the goal is and then what's good enough. What's an acceptance criteria? That's a term you hear product managers use a lot. Is how do I know it's good enough? Well, you give it something that says, if it does these things, it's good enough. So, you know, essential to getting software to do what you want is, again, knowing what you want, describing what you want, and then describing what you want in enough detail to assess the outputs. Often these three things happen kind of in sequence where you say, what do I want this thing to do, kind of at a high level? And you say, great, I'm going to write that in a sentence that's as detailed as I can be. But then I'm going to take that second sentence and expand it so that there's detail that'll help me assess the outputs. And the interesting thing here is that unless you're really good at writing acceptance criteria, just live with the fact the first pass is going to miss stuff. But then when you really use it and you say, all right, I've got some outputs, I'm looking at it against oh wait, I forgot something. That's okay. Add it to your acceptance criteria. Now you're in a good place to continue to move forward. So the point is you're iterating in a bunch of different ways. So this is me. You saw earlier that I'd done a what do you call it? A normal curve. Well, I first prompt, please create an image of a normal curve. Well, it does something out of a textbook, which is not wrong, but it wasn't what I want. So I said, it's too much detail. I don't need the notation. It doesn't help with my argument. What I really wanted is down here. So please create an image of a normal curve, just the curve, no notation. Well, a lot of these, what's it called? Diffusion models really like to make 3D and make things look cool and sexy. So it basically gave me not quite a cone, but kind of a cup, an upside down cup. I said, all right, well, I don't really need it to be that tall, although that's not the big problem. It's 3D, which isn't helping the argument because I really wanted to show this distribution. So I said, all right, please create a simple line drawing of a normal curve, no notation against a black background. And that's what I got. So the point of all of this is it's a simple thing, but I wanted something. And my options were to play around with this or to go and try Google searches for images. And I didn't find what I wanted from that. And so I stuck with this. But my point is really simple example of a broader point. If you do something often, as I say, whether it's things like receipts or getting documents from people, searching through documents, whatever it might be, but you do it often enough, it's worth doing this. It's worth going through the steps. And all I did here was put some structure around it. As a friend of mine from BCG used to say, think in a framework, and it just really helps you to organize your thinking and get, know when you're, the other part is know when you're done. So The other thing to note about this, though, is as annoying as this might feel, the cool thing is for the first time, AI can help you to debug AI. So you can write a prompt into whatever it is you're using. Tend to use ChatGPT. I'm creating a PowerPoint slide. I need a very simple normal curve, just a line with no notation, yada yada. Please write a prompt for that. And it did that. So the other thing that's interesting is as you go through this structured set of steps, you don't have to do all the thinking yourself. You can pop it into ChatGPT and say, do a better job. And I promise you that's going to mean you have fewer steps than you would if you just did it yourself. So the cool thing is for the first time, as you think about debugging, AI can very often help you. We are finding that that's actually sort of the next frontier in AI automated code development is how to do debugging better. It's not bad, it's not as good as we want it to be. But for what I'm telling you to do as a non-developer, that writing better prompts is something AI is often very good at. So this is sort of next level debugging. So we've talked now about you just doing it with your own structure. Maybe you're creating a table, whatever. But the other thing that's really interesting, and this is really where people have turned software, turned what I talked about and turned it into software that allows you to do these frameworks. These are three that I'm aware of. Of course, they all have prompt in the name. That's why they look similar. Prompt layer is something we know really well. And what it allows you to do is store your prompts in one place so that you can test them rigorously more than once. You can set up testing regimes so that you can say, hey, I want you to do this 20 times and show me what's happening. It's structured testing. You can integrate with ChatGPT. You can integrate with agents. We did it with SpecGPT, our software. And the point is there are evaluation mechanisms that allow you to test your prompts. So this is probably more than you're going to want. I bring this up because it's important for people that are interested in this space, that are doing things in this space, to know that even the evaluation is becoming more and more either automated or certainly aided by software that's purpose built for exactly this. So these three folks are focused on prompts, which means they're valuable for you. And of course, if you're building software, but also you can plug this into some of the no-code tools that you may be using as well. Now, some of them, I didn't get into no-code tools today, but some of them like Make or Zapier have their own evaluations. Frankly, it isn't their strength, but it's something they recognize they need to do and they're getting better and better at. So you can often say, hey, the prompt part, I'm going to separate out and have prompt layer help me with. The other parts will have the automation software do. So the point of all of this is to get in the habit of being a little skeptical of what happens at scale. So understand how the evaluation is happening. The problem we always have with AI is it looks so clear, well formatted, and confident. I use that word almost tongue in cheek, but it looks like something we normally think would be good. And it can be, but you're going to find the edge cases are where it breaks. But because in aggregate, edge cases happen not infrequently, it's going to break. And as anyone who's actually demoed software knows, the time when AI, when any software chooses to discover an edge case is when you're showing it to somebody, and the kind of demo demon, as we used to joke. So you should be testing and evaluating before you can, rely on it, but you should also be asking about that when someone comes to you and says, "Hey, I've got software that's using AI, it's doing amazing things." Ask to see about their evaluations and what they're doing. More so than normal software where you just assume they've got a group of people that are debugging and dealing with patches and all that stuff. In the case of AI, it's a new skill. It's not the same as classic debugging because the inputs are so fuzzy. Um, and again, why you should bother. As I mentioned a moment ago, the tools that people who aren't developers are using are really proliferating, and you're going to start seeing abstractions that are allowing you to do pretty cool things. And back to this thing, we're kind of at the beginning of an adoption curve. I also don't think that's a normal curve for those of you who are nerds about adoption processes, but whatever. We're right here. And I mean, this is just me, this is notional, but we're early in this, right? Very few people are actively using these things. And when they are, it's usually as a curiosity. But as it starts to become part of how people do their jobs, you don't want to be caught here and not being able to, make sure this stuff works. So now is the time to be thinking about how do we debug? How do we think about this stuff? in a way that is reliable and allows me to just have a tool I can use instead of something that works sometimes and then I just, abandon it. So as I say, to me, this is the next level. This is where people start to go across the chasm, so to speak, from, yeah, it's cool to it's reliably useful. Tools that save time, tools that save work. So by developing this stuff, by debugging, you can create a tool you can count on. So the next step here, and everybody's talking about agents, it seems like everywhere. And actually, that's what made me want to talk about this today is in the middle of agents are these are usually it's an LLM. I don't know that that's always going to be true. So everything I just said about large language models and chatbots and all that, often there's effectively a chatbot in the middle of an agent, depending on how you're developing it. So you're back where you were before. So these are often multi-step. A lot of the steps in them are not necessarily AI mediated. There's almost always an AI in the middle of it, or we wouldn't be calling it an agent. But the point is, evaluation is even more important here because the mistakes and errors can compound, right? Because you're taking one thing becomes the input of the output of one becomes the input of another. And if you're starting in a bad place and then iterating, it can just get worse. So here's where you're going to want to start with more than just your acceptance criteria. You're going to want to think about understanding the breadth of use cases where it might be used. So where will it get used? What are the inputs going to be? What are the expected outputs? So that you can start isolating steps and testing them yourself. Again, the tools I showed you a moment ago, including just making your own table, I think are really helpful here. This stuff is tedious. It's worth knowing it's tedious. As I said, it's as much an attitude as it is a skill. But once you've figured that out and you've just said to yourself, I'm going to caffeinate, lock myself in the room for 4 hours, it very much will pay off. Acceptance criteria, again, what is good enough? Sometimes you can engineer the other thing that's important when you're thinking about something that's a little more like a production product, like an agent, is you don't always need it to be perfect. One of the key things with all AI is what's good enough. Like what's my level of accuracy that I need because it's handing it to me and I can just take it and do what I need with it. Think about the user interface, the overall user experience. Can I call it just a draft? Is that what I need? Like, great example, a lot of the automations people are doing right now are, hey, look at all of the flagged emails and draft a response. That's good enough. It doesn't need to be a perfect response. It needs to have given me a start that I can edit, right? Or you're including a human in the loop, which is effectively the same thing. Except when you say human in the loop, it could be that it's not a draft. It could be that you have a dashboard or some way of looking at the outputs or even the interim outputs. But anyway, creating powerful tools to course correct. One of the things that OpenAI has done with ChatGPT that I absolutely love is their Canvas product. If you haven't used that, if you tell it to write something in Canvas, it basically gives you kind of like a Google Doc where you can go and edit right in there, right in the tool. You can also highlight things and say, hey, give me some other examples, rewrite this, so on. But the point is it gives you powerful tools to course correct, which I really like. And then, of course, creating tests to indicate when outputs are outside of a range. And that's, again, kind of a UX thing as well as just a good idea. So when you think about agent evaluations, this is the part where I'm seeing a lot of progress and a lot of movement coming out of Silicon Valley as well as other places where they've created products. Arise is a really good one. There's some other ones out there. Um, it's not hard to string together functions into an agent. It's not hard to dump content into an LLM and get some answer. It's really hard to do the steps I put here. We're understanding requirements. You're defining what success looks like. You're creating acceptance criteria. From that, you're developing tests. And from that, you debug and then you retest, you deploy it, it breaks, you debug, you retest, you deploy. It becomes, one of those things where you're halfway to the wall and then you walk halfway again and you walk halfway. You never quite hit the wall, but you get to a place where the number of edge cases left is small enough that it's reliable. So hopefully that kind of diatribe opens up some ideas and some thinking about where we are and how AI can now become more useful for you and the people that you work with, whether they're developing products for you, whether you're buying products, whether you're specifying products. All of this to say that AI is going to continue to be dangerous in that it lulls us into thinking it works better than it does. And it's important for us to stay vigilant and say we have not been able to alleviate or eliminate the need for the long tail of software development. It's still there. It's easier than it was. People that are not software developers can get involved. I do think asking a software developer for advice on this is not a bad idea because all of them are good at this or they don't have a job. Um, so that's the big one there. I'm going to end what is always going to be a shorter session today with a note on technology progression. So actually, my master's thesis was diffusion of innovations, which is why, again, I nerd out on probability distributions and stuff like that. One of the things that we see a lot is rapid, oh my gosh, it's so cool. And this is a little bit of what Gartner talks about with their hype cycle. We see this, and then we assume it's going to do this so often. And AI is really, you've seen this a lot, but I've seen it in other things too. I saw it in broadband. I saw it in digital music. I saw it in VR, especially. Oh my gosh, did I spend time on that? So we think it's going to be like this, that it's just going to keep getting better at the same rate, and that never happens. The best you hope for, and this is kind of what's happened with Moore's law, is one set of technologies kind of peters out, but while it's doing that, another one comes up. Crazy things like, in the case of Moore's law, really different ways of masking, and the foundries are just unrecognizable, but even they're stacking things in 3D, all sorts of things to continue to have this progression. And you hope that there's another technology that catches the general curve so it continues to go up. But sometimes it does this. And this is what has happened with VR, for example, where Oculus was absolutely a leap that's right around here, and things got better, but not enormously so. Like the big leap was actually not even VR. The big leap was in mobile phones and display technologies that Palmer Luckey was able to, figure out, and then he got Cormac to kind of productize with him. But after that leap, there were improvements, and there continue to be, and untold billions have been spent on this. But in terms of what real people can use, a lot of those improvements have not really been a new S curve. They've just been kind of eking out new progress here. We may get there. There may be some big um, breakthrough. But for those of you who've been watching the AI space or been paying attention to it for a while, will know that actually AI as an idea came about in the 50s, and actually even earlier than that, if you want to credit Turing for it. But we've had these things called AI winters, where the current S curve ran out of gas and things got incrementally better, and then something changed. Usually it was compute. So some of the improvements here actually found a home, like so neural networks and deep learning as an idea dates back, decades, but it didn't make sense until we had compute and data, which got us to where we are now. I say all this to say that as we think about the progress of AI, it's important not to assume that the next S curve is absolutely happening when we think it is. Now, we are in a place where the amount of money spent on this is absolutely unprecedented, but it's important not to think that the next one is going to happen quite as quickly as we want. It's going to happen. I think that's a reliable prediction. But I think everyone assumes, and this is why it matters for you, is when people have products that are assuming that the next model sets are going to necessarily make their bugs and shortcomings better because everything's going to improve at the next step is unrealistic. The improvements that we're seeing are often not quite in the same direction that we thought. A great example, you could argue that pre-training was one S curve, and test time training, for those of you who are familiar with what GPT O1 and O3 are doing, and for that matter, DeepSeek and some others. It's a new S curve and it's better. So the point is, overall, the technology will get better, but assuming that one thing will continue to get better I don't think is realistic, and I think is a little bit dangerous. So you can't know that a given model or approach is going to necessarily get better. You can assume that AI, the trajectory is going to hold. The point here is, as I showed with VR, sometimes you hit a wall. So all technology progress is a series of those S-curve developments. Sometimes the next development can take longer than we want, whether it's to create it, to stabilize it, which is a big deal, or commercialize it. We expect AI to continue getting better. We're going to hit walls here and there. That said, that is the point I made earlier, is that the AI has trillions of current and future investment, kind of unique in history. So unless there's like a law of physics wall, if it's just technology, that the number of competitors is probably going to mean that we'll continue to see progress. But I wanted to go through that because I don't hear people talking about that S curve thing often enough. People just take the current progress and assume that relatively smooth progress is true at a lower level where you're talking about individual technologies, as I say, like pre-training or various other things. And frankly, it's not. And that's one of the reasons why the folks like OpenAI they have more than one thing going on at once, more than one technology type, more than one stream of research, because you just don't know where the next breakthrough is going to happen. A final point here, everyone was really focused on tweaking deep learning algorithms and so on. And actually, when Transformers came out in 2017, they were one of a number of good ideas. They turned out to be the one that had the most promise, but it wasn't the only thing that really catapulted AI to the next S curve. Because classic deep learning I wouldn't say it hit a wall, but it had hit a point where people kind of knew what to do with the state of the art, and it was moving along, but not in a way that was commercially that interesting. And all of a sudden, in 2022, there we go. So the point is, don't place trust in the form or pace of future progress. It's going to be progress. It's going to be fast. Almost definitely going to go in directions we can't predict. As I say, before DeepSeek, open source was second class. You heard about it, and Llama was out there, and it was cool, but just didn't hear about it as much. Certainly not outside of some of the startup world. Um, Now everybody's talking about it. Even OpenAI is saying maybe we should do an open source. Whether they really do, we'll see. Distillation is another one. So for those of you who don't know what this is, it's really cool. It's you take a big model to create a small model. It's one of the things that DeepSeek did to kind of short circuit and more efficiently get where they needed to get. Now everyone's talking about it, which is great. So all of this to say, you don't always know where the directions are going to be, and they're not always driven by technology. Sometimes they're driven by what's going on in the marketplace. So that, folks, is most of what I wanted to talk about today. So to close, real, reliable, rigorous AI products, they're hard. It takes real work. AI is powerful, but it's not perfect. It takes that work to make it not perfect, but reliable. So to go from just prompting to writing an email to real impact, you need to put in the work or have someone who does. Hire someone like the link, like our consulting, but there's a lot of people out there that can help you with this. So that's it. That is what I wanted to get through today. I showed you guys before that there's a bunch of these recordings up on YouTube. I'm going to put this up on YouTube as well.